Good morning. I think we need to understand how to design a brakes in terms of, I think, from the thermal aspect. So we know that brakes actually convert kinetic energy into friction, and therefore they stop the vehicle. And because of that, heat is generated in the brake pads. So brake pads and the disc interface, or it could be like brake shoes and the brake drum, and that heat, where it has to flow and how much is the heat generated, how much will the elements get heated up in terms of centigrade. We'll have a just look into it, because there is no separate subject for this, because even we had earlier design of automotive components, but we did not have any aspect like this. Maybe for SE also you need this. Okay, now just look at this. So this is a very simple problem. Estimate the heat energy produced at the brakes when a vehicle of 1000 kg decelerates from 108 to 72 km per hour. This is the problem. So we know that energy can neither be created nor be destroyed, right? So when a vehicle slows down, kinetic energy is lost, and it has to be converted into some sort of energy. Here, since the brakes are actually converting the friction, all this kinetic energy should be converted into heat energy. So let us find out what is the kinetic energy lost. So kinetic energy lost is, you know, the formula of m square. So that is final velocity minus the initial velocity. Sorry, the initial velocity minus the final velocity, whatever. You can actually say this. So here we know that 108 km per hour is nothing but 30 meters per second square. I think you already know this. We have used 36, 72 and 108. Okay. So 36 is actually 10 meters per second, 72 km per hour is actually 20 meters per second, 108 km per hour is 30 meters per second. So this 108 km per hour is actually 30 meters per second, 30 square is 900. And the 72 km per hour is actually 20 meters per second. So that is 20 square is 400. So this difference in velocity square multiplied by mass multiplied by half. So half m square is the formula. So you get a value like 2,50,000 kg meter per second square meter. So this is, so kg meter per second square is nothing but newtons. So this is newtons. So Newton into meter. So Newton meter is joule. So you get this as, so if you actually take this 3 zeros, then you can write this as 250 kilojoules, because you are eliminating this 3 zeros here. And you know that Newton meter is nothing but joule. What is joule? Joule is the amount of work done when you apply 1 Newton of force through a distance of 1 meter. That's called as 1 joule. Okay. So Newton meter. So this is newtons. This is meters. Newton meter is joule. So you get this. So this unit is the same unit of heat. So that means we can actually find out how much is the heat generated. This heat can be used to calculate how this brake system would actually be heated up. So this is the basic formula. Then we go to the next step of next rules. So you know that, of course, the brakes, suppose if it is continuously heated, suppose if it is continuously, the vehicle is undergoing deceleration due to braking. So continuous heating of brakes would lead to the brake discs becoming deadlocked like this. I think this is a very unacceptable thing, because we have what is called as brake fade. So brake fade, I think you know the English meaning of the fade. Fade means what? Fade means what basically? You say your shirt got fade. Your shirt color got faded. That means if it was good earlier, it is slightly reduced. So fading is actually reduction in capacity. Reduction in capacity. So let us see this now. When these brake pads get hot, what would be the reduction in the coefficient of friction? So very good brake pads can give you coefficient of friction up to 0.8.